So here I have a car going around a turn. Okay, hopefully you guys can see my picture. Hopefully it makes sense. Once again, the D stands for driver, and the P stands for passenger. Okay, now we're gonna start off today with a little story that my grandpa used to tell me. It's called about a curve near his childhood home that he called Benifit Curve. Okay.
Is that a legit story that he used to tell you?
Legit story.
Alright.
I have been told this before.
Benefit curve. Okay.
Yep. Benefit Curve.
What we gonna
Okay.
learn today?
Now, timing here is perfect. You guys got Valentine's Day dancing Saturday. You guys come on too. Okay. But Grandpa used to tell me about this curve by itself that he called Benefit Curve. Now, back in the old days, cars were designed a little differently. Number one, they didn't have seat belts, and you weren't required to wear them because they didn't have them. Okay. Number two, the seats weren't individual bucket seats like we have now, right? There wasn't a console in the middle where you could put your drinks and your change and everything else in your iPhone, whatever else you have in there. Okay? There was no console. It was what's called a bench seat. So when I say a bench seat, what does that mean?
Like in trucks, like how it's a bench.
It's a bench, right? It's just one long seat, right? Right? You sit here as the driver. You sit here as the driver. The passenger sits next to you, and there's just seat between you, right?
Oh, like a carrot. You know how like the horses or whatever, carousel. That was, no, that's not.
Isn't it like when
Like a carriage?
when the truck?
Yeah, carrot.
Okay. Okay, I see what you're saying. Getting really into Valentine's thing now, aren't you?
Oh, yeah.
I don't think the horse and buggy will go fast enough for this, though. It might not work. Okay. Now, another thing they used to make... What'd you say, Derek? Depends on the horse, yeah. And how many.
Black Stanley.
So, when I say bench seat, you guys all know what I mean?
Yeah.
Everybody seen a car with a bench seat before?
Yeah.
Yeah.
Passenger truck. All trucks have that. Bench.
I don't think all trucks. A lot of older trucks have it.
Yeah.
Okay. But basically, there's just one solid seat, one solid surface that goes from the passenger to the driver. Now, one other thing that used to be true about a lot of cars, they used to have leather seats too. It's either leather or it was vinyl. Both of those surfaces have a low coefficient of friction. Okay. So what does that mean? They're slippery, right? Okay. So what Grandpa used to tell me about Benefit Curve is when he was going on a date with a girl that he liked, you know, if he was taking out his cousin, then he wouldn't do this. But if he was going on a date with a girl he liked, he would go around this curve and he would make sure that he was going at a speed that might be a little greater than normal. Okay. Why do you think that's the case?
So that way, the passenger, would like slide on the surface of the bench seat or whatever to get closer.
Okay, so as they're going here, she's sitting over there, he's sitting over here, and as they start to curve, what happens to the passenger?
She gets closer to
She might inch a little closer, and a little closer, and then when they leave the turn, they're sitting right next to each other, right? So Gramps used to be in the car, he used to put his arm up like this, go around Benefit Curve, and his date would slide over and be sitting next to him with his arm around.
Grandpa was the first person to drive with him.
Maybe he was, you know. So it's a great idea, this little 57 Chevy, right? I shouldn't say little, big 57 Chevy. This is huge. Okay. Maybe it's a little too old, a little too young for Grandpa. All right. But you guys got the idea here, right? So why does the passenger slide out? Sergio.
There's no seatbelt to restrain the movement of the passenger, and because like the coefficient of friction is low, then that's easy to slide.
Okay. But what do you know about things going in circles? You are right about nothing to restrict them and the coefficient of friction being low, so it's easy to slide. But what do we know about circles? Which way is the force acting on something around a circle?
Oh, because don't they have to go like?
Which way is the force?
To the
Towards the center. So as the car goes around the circle, it's going to have a force towards the center of the circle. We'll say this is the center of the circle right here. Has a force towards the center of the circle, right? So why does the passenger slide out?
Uh-oh.
Why does the passenger slide towards the driver? If there's an inward force, why are they moving in? Why are they moving out? Was that there a little louder?
They don't have enough force to stay where
They don't. What kind of force? Centripetal force.
I don't know.
Okay.
I'm winging it.
You're winging it? All right. Well, you're getting close.
It doesn't have to be centrifugal force because they're moving towards the travel not towards the center.
Okay, so Sergio brings us this idea of centrifugal force. Now, I know we brought this up before. Okay, is this a real force or a fake force?
It's all in your head.
It's fake force.
Real force or fake force?
Fake force.
Fake force. Does that mean my story's fake?
No.
Have you guys all felt this before? You're in the car, you go around and turn a little too fast. What happens?
Like
Your body leans
Your body.
back. Yeah.
Your body leans inside or outside?
Outside.
I have conflicting opinions here. Okay. So when we're going off M6 onto 131, right? And there's those big circular turns, and you're taking those going about 55 miles an hour. I think that's what posted speed limit is, maybe 35. All right. Which way is your body being pulled?
Inside.
Which way is it being pulled? Inside and outside. Anybody remember doing this before?
I'm pretty sure it's inside. I'm gonna feel down like it's not inside.
Do you have the little hanging dice in your rearview mirror? And we're turning that way. The hanging dice go that way. Okay. So if I'm turning this way, my body gets pulled
Inside.
outside to the outside. If you don't believe me, try next time you try it. Think about it as you're going down M6. Okay? As you get on those big circular on-ramps, your body gets pulled to the outside of the on-ramp. Okay. What prevents you from sliding like the passenger does in Benefit Curve is your seatbelt.
But then why does the passenger slide to the driver?
Because this was an old bench seat.
No, I mean.
Okay, it doesn't work anymore. Let's in the back seat. In that case, you should sell your seatbelt. All right. But so the fuzzy dice slide to the outside. The passenger slides to the outside. Why? We said this was a fictitious force. Remember, centrifugal force is a force or acting away from the center. So centrifugal force. Oh, slipper came off. Trouble teaching in slippers. It's a force acting away from the center, right? That's what centrifugal force is. So, is the passenger experiencing a centrifugal force?
That's close. It's just
But it's a fake force, so then.
wants to stay above.
You're stuck, huh?
If it's a fake force, then how can you experience that?
Okay, how can we experience a fake force, right? Right, that's what Sergio's asking. Does anyone have any other ideas what's going on here? Richard. Okay, so Richard said, isn't the force being applied to the car? Well, what's applying that force to the car, Richard? The car? You said the wheels? Lynn, you said something?
Friction.
Friction, good. There's friction on the wheels of the car that's causing the car to go in that circle, right? Friction is responsible for turning the car. Why doesn't the driver slide outwards? Because there's a door there. Interesting. What does the door apply to the driver? A force. Which way? Inwards. So the driver has a big force, has something to apply a force inwards. We said it was the door, right? Okay. Maybe that makes it a little tough to read. We'll draw the driver's force above him. Or her, depending on who's driving the mistake. Well, it's my grandpa's story, so he's driving.
Mr. Brand, to be honest, did you ever try Benefit Curve?
When I was growing up, we used to play a game in the backseat of my parents' station wagon. We called it G-Forces, but it isn't G-Forces. Where when my mom would turn around the corner, we'd all slide, and we'd exaggerate it. So, like, as she's turning this way around something, we'd all slide to the outside and try to body check the person on the outside.
How old are you when you were doing that? You call it Jeep.
15.
Oh, Jeep.
Oh.
No, I'm just joking. My brothers were, I'm the youngest of four, so my brothers were all older than me, so that's just what they called it.
Oh.
Wait,
I was usually in the middle, so I was just getting beat up back and forth, but it was a fun game.
Wait,
so-
but actually ever tried Benefit curve out, like,
No, I never had a car with a bench seat.
Come on.
So
That sucks.
one time I took my van around the corner real fast, and my buddy who was in the back seat sleeping on the inside ended up tumbling to the outside. It was pretty funny.
I remember my head hit against the window because I wasn't wearing the seatbelt.
All right, back to this. Always wear your seatbelt. All right, back to this. So the driver feels a force from the door, right? Assuming they have the same thing happening to them as the passenger does, right? So the door pushes the driver, and so why is the centrifugal force not acting on the driver?
Because there's a force keeping them like stable, I guess.
Okay.
Right against the door.
Because the door is like what?
So it seems like this force is only acting in certain situations. It's kind of picking and choosing, right? Now, from what we've learned about physics, do forces only act in, like, is it kind of, are forces choosy about when they act?
Yes.
Or is there one rule that kind of governs everything?
One rule.
One rule, right? There's one rule. Newton's 3 laws of motion. There's actually 3 rules, right? Newton's 3 laws of motion. They govern everything, right? So this centrifugal force, it can't just act on sometimes and not act other times. It has to act all the time, right? That's why the centrifugal force is called a fictitious force. What does fictitious mean?
Fake. Non-real.
Is that how you spell fictitious?
No.
No?
Factitious.
How do you spell fictitious then?
I think you should put a K.
I don't think it's a K in it.
I think just a K.
I think it's how you spell fictitious.
Hold on a
Factitious.
You think it's right? Thank you, Shelby. Yeah, it is a fictitious force. Good, I got somebody involved regardless of what the reason is. Yeah. It's a fictitious force.
Factitious force. That's what I see.
The reason why it's a fictitious force is people come up with this idea to try to explain why the passenger moves to the outside. Well, I got spell check out. We'll see if I'm right. Nope, I am wrong.
K.
No, I'm right. I spelled it incorrectly on Microsoft Word. That's right. So I'm 1 for 2 on this word. So it is a fictitious force. Okay, like I said, people come up with this idea to try to explain why the passenger moves to the outside. Okay. So let's think about Newton's laws.
First one.
Newton's first law. What does that say?
Object in motion stays in motion.
An object in motion stays in motion.
Yeah.
Now, who's all in motion here?
Passenger.
Passenger, the driver, the car. Okay. Now,
And the destination.
at this point right here, which way is the passenger moving?
Forward.
Forward, right? Kind of up, right? So I'm going to draw a line. I'm going to draw a line that represents a dashed line that represents the direction of the passenger's velocity at that spot. And what do you notice about those two P's?
They get closer to
The first P and the second P.
they get closer to the driver.
They're on the same. This first P and that second P, they're on the same line, aren't they?
Yeah.
Right? So the direction of the passenger, their velocity isn't changing when the car starts to do what? When the car starts to turn. Their velocity isn't changing. Their velocity is staying the same. Does that make sense?
Yeah.
So why is the driver's velocity change? Because the driver, if I do the same thing for the driver, right? They're inside of that line, aren't they? Right? So the driver had to have, they moved a little bit, right? They're not on that same path anymore, are they? The passenger remains on that path, the driver does not. Because the driver is experiencing a what? Not centrifugal. A door force. A door force directed towards the circle. The driver is feeling a door force directed towards the center of the circle. It's called a centripetal force with a P.
Oh, yeah.
Centripetal, not centrifugal. or centrifugal if you want to be very, make sure you know exactly what you're talking about. Okay. The driver feels a centripetal force from the door, which takes him off of their path. Right? Is the driver staying in motion?
Yeah.
No, it's being acted upon by a force, isn't it? Well, the passenger. An object in motion stays in motion unless acted upon by an outside force, right? So this passenger is staying in motion, right? They keep going along that path, which then does what to them? Moves them closer to who? The driver.
Oh. So it's like if the car stops, they're gonna go flying out the window, out the front window.
Similar idea, yep. If we were to slam on our brakes, you feel force going forward, right?
Oh, like
That's Newton's first law, right? Newton's first law, that object in motion stays in motion, right? So here the passenger is staying in motion. Okay? They're staying along the straight line path because no force is acted upon them yet because that leather seat is really slippery. Okay, okay, so Sergio, pay attention please.
I was just talking
Then,
about force and stuff.
At some point in here, what happens? Some point between the second car and the third car, what happens?
They turn.
Who turns?
Okay.
Nope, they're already turning. The turn has started.
Well,
Steering a little more.
isn't she already in contact with the driver? Like already as close as they can be?
The
Nope.
passenger starts sliding.
Okay, the passenger starts sliding. Well, the passenger already has started sliding. Okay, they're further from the door than they are down here.
And by the time they're already together.
Okay, so what causes the passenger to turn when they do what?
When they still want to stay in motion.
Okay, they're going to stay in motion until what happens?
Acting on by an outside force.
Okay, who applies that force to the passenger?
The driver.
The driver. So at some point in here, the passenger and the driver make contact. Right? The passenger and the driver touch. Right? Then what happens?
Yeah, the passenger doesn't move anymore.
No, the passenger's still moving. The passenger doesn't slide outward anymore. Why doesn't the passenger slide outward anymore?
Because the guy, the driver,
The driver does what?
has the force. He has the outside force away.
Okay, adds a foursome. Which way, Kevin?
Inwards.
Inwards towards the
Center.
center of the circle. And that force now starts bringing the passenger in line with that circular motion. Okay. So, this centrifugal force, this fictitious force, in this case, the outward force, oh, right there. I want to get that force acting away from the center. In this case, the passenger feels a force, with air quotes, right? A force acting outward, because why?
The velocity is not changing.
The velocity isn't changing as a result. Remember, centripetal force has a requirement, doesn't it? Force centripetal equals mv squared over r. Right? That is a requirement for centripetal force, right, Nikira? In order to keep the passenger going in this circular path, there has to be a force that equals mv squared over r, right? Right? We talked about that on Friday. Remember the icy on-ramp? Car slides off. Right? In order for the passenger to keep going in the circle, there has to be a force that supplies this many newtons to keep the passenger in that circle. Is there a force that supplies that many newtons to the driver? Yeah, what supplies it? The door. Is there a force that supplies that much to the passenger until this point right here? Is there a force that applies this many newtons to the passenger until we reach that spot?
Until you reach it?
Yeah, so before.
No.
So from here to here,
No.
is there any force that gives us that many newtons? No. There's no force that gives us that many newtons. So what happens? They keep going straight, right? Or they stay on their original path. Okay. Because the force of friction between the passenger and the seats of the car is less than the required mv squared over r. Okay, does that make sense, guys? Right. So we can write, is this centrifugal force, this is a result of a force being less than mv squared over r. And since a force is less than mv squared over r, that means I'm going to write N1 right here. When I write N1, what does that mean? Newton's first law. Right? So, the centrifugal force, the reason why the passenger experiences this, quotate, or air quotes, outward force, right? The reason why they experience this outward force is because the force of friction on the passenger is less than mv squared over r. So there could be different situations, not just with a passenger in a car. Okay? It could be a tension if it was like a wiffle ball situation. Could be a tension if it's the rubber stopper and the washers. You guys remember that, right? The rubber stopper slid out, didn't it? When you swung the rubber stopper faster, it moved out, right? Right? That's because the tension was smaller than mv squared over r. Right? Anyone ever see what happens when a comet approaches Earth? So here's Earth.
Looks like a baseball kind of.
And there's Earth, right? A comet. It's a really big comet. Does one of those things, right? That's because the force of gravity from the Earth isn't big enough to keep the comet in orbit. The comet comes around. It does one of those, right? So, this centrifugal force, this fictitious force, acts, or I guess I'm using acts kind of liberally there, right? This centrifugal force appears when this happens, when the force that's being applied to the object, whether it's tension, gravity, or friction, is smaller than the needed centripetal force to keep the object going in that circle, and that's when we get this outward force. All right. Does that make sense? So what really causes this? What really causes this right here? Is there really a force? Is there really a force? No. Okay. What's it really caused by? Your brain. Velocity. There's a special I word I'm looking for. Someone said it. Inertia! And Sergio stole it.
Ah, yay!
What's inertia?
It's the resistance of an object to move,
Not just to move.
to accelerate.
Oh, there you go. To accelerate.
Yay!
It's the resistance of an object to accelerate. It's the resistance of an object's change in motion. Right? Remember when you're walking with your lunch and you have your orange in your lunch tray and you stop walking and your orange keeps rolling? Right? That's inertia. Or when you're sitting in your car and you hit the gas after a stoplight and you feel you kind of move backwards, right? That's inertia. It's a body resisting a change in motion. So this passenger, they're resisting a change in motion. So they're staying on that path until the driver applies a force to them. So this centrifugal force is really a result of inertia, okay, and Newton's first law. Okay, because the passenger stays in motion until acted on by an outside force. And I put the P. The P means the passenger. The passenger stays in motion until acted upon by an outside force. And who applies that force to the passenger? The driver. And therein lies Benefit curve. Okay. Now, When the date's done, you know it's 9:30. The driver's bringing the passenger home, right? Being a respectful young man. Driver, passenger. Date went well. Okay. The driver didn't make too much of a jerk of himself, you know. Didn't text too much while they were talking. All right, wasn't on Facebook the whole time. All right. The driver's coming back this way. Will Benefit curve keep its name? Coming back around this way. Take a moment, think about it. Don't shout it out. Okay. Will Benefit curve keep its name coming around this way? Or basically, what I'm asking is, as the driver comes or starts turning this way, what will happen to the passenger? Okay, I don't want you to shout it out. I want you to think. No, okay. Take a moment. Give me a shot. Okay. Is it still Benefit curve?
Yes.
So think about it. What will happen? Is it still Benefit curve? Kevin Jones, got an idea? Yeah. Is it still Benefit curve? No. No, why not?
She'll slide away.
She'll slide away, are you sure?
Yes.
How do you know? What force?
The force that the driver on the circle causes.
No, the driver on the circle is an inward force.
Yeah, she's not changing until after another force.
Okay. So remember, as the car goes around the circle, it has an inward force, right? Okay. So Kevin's right. The passenger will slide away from the driver.
Well, she won't, because the driver's gonna, have the arm around her.
Gonna have the arm around,
Yeah.
but not just resting on the back of the seat, but actually, like around her. I got you, around her shoulder. Well, let's say he's just kind of relaxed. Okay, he's having the arm around the shoulder.
Well, that's his fault.
It is his fault. Maybe the date didn't go that well, and he's trying to be subtle.
I mean, yeah.
Okay.
I'd be dangerous. I'd try and go.
What?
Wouldn't that be dangerous?
A little bit. That's why we have seatbelts now. All right, so the driver goes around the curve. Kevin's right. The passenger will move out. Right. But what confuses us is that there's an inward force, so we would think that the passenger is going to stay close to the driver because there's an inward force keeping him in the circle, right? But the same idea applies. An object in motion stays in motion. So if the passenger has a motion this way, right? Where would they be if the car wasn't there?
Walking.
Walking, okay. Hopefully, right? If that door, if the car door flung open, right? The passenger would end up right there, right?
This just in on Fox 17.
There you go. So where would the passenger be?
In the hospital.
Okay, but let's say the car door stays closed. It's locked. Okay, where does the passenger go?
On the passenger.
All the way to the end.
Side door.
The passenger ends up out here, right? Sliding away. So when you come home on Benefit curve, you got to make sure that, like Sergio said, you got to make sure that you have your arm in the correct location. Got to have correct technique, right? Otherwise, the passenger slides away from the driver. All because of centrifugal forces or Newton's first law.
Newton's first law.
Newton's first law. Okay. This idea of centrifugal forces does not exist. All right. It's Newton's first law.
Then why is it existing? Like, why is it centrifugal force if it does not exist? Why does it exist if it doesn't exist?
Because sometimes things get explained before people actually know what's going on.
Okay. That doesn't make sense.
Well, sometimes people explain things and they try to make it as simple as possible. By making it as simple as possible, they actually make it complicated. Okay. So I don't know if you've seen the water bucket demonstration before. Okay, and you swing around and get the water in the bucket. I don't know if you saw that before me, but there has been. I'm not saying that our elementary school does this, but there have been elementary school teachers in the past, and middle school teachers, and high school teachers for that matter, who swung a bucket of water around and said the reason why the water stays in the bucket is there's an outward force acting in the bucket. Okay, and that is incorrect. Okay, and that was believed for a time too, until we started looking at it with the centrifugal force ideas. All right, Newton's 3 laws, they apply in every situation. We can't pick and choose when they apply. So this inertia law applies all the time. And this makes better sense thinking about inertia than it does thinking about a force that happens sometimes and doesn't happen sometimes. Right? Any questions about Benefit curve and centrifugal force?
Where exactly is that located?
It was actually just a joke. Or not a joke. Just a teaching tool. Okay. You can try, but you better encourage your date to wear a seatbelt if you really care about her. Okay. And you'd have to be going pretty fast to get your date to go over the console, because most cars have a center console now. It would be dangerous. You might not have enough friction in your tires. Okay. Anyone else?
Alright, what are the best tires?
What are the best tires? I don't know. Go to Bell Tire, Discount Tire, and have them tell you.